Hey everyone, welcome to week 2. Hope you've all had a stunning first week of uni, whether it's in COMP6080 or any other course. I think I just wanted to start with a pretty simple question for those who are on the live stream, which is about how's the first week been? Do you have any questions? Is there anything that's been on your mind? Concerns? Like just a few minutes at the start to see if there's any big things to chat about. There's obviously always the slight lag in the stream, so adjust for that for a moment. So just while people are answering, if anyone even has any questions, the first week we pretty much just focus on, like, the first week was just the exercises and the tutorials. DaVentures asked, will this lecture include blurs? No, this lecture won't include blurs. A lot of the parts, so with the first assignment, part 4 is really designed for some of the latter bits of content. So in parts 1, 2, and 3 are pretty much all about what you learn in week 1. So parts 1 and 2 are all done, like these were released before you started the course, so that's all you need to do, parts 1 and 2 of the assignment. For parts 3, you can do a lot of part 3 with just these early lectures, but you also need to have a look at probably the CSS mobile intro for part 3, because that's the responsiveness part. And then for part 4, it's pretty much actually just these topics here. So that's anything with the grapes. So the purple grapes is like intro, DOM, events, forms. All of the lectures there are there to watch. So that's where you can, that's where you can get into it. Zenji says there's no submit button in assignment 1. Okay, let me take a look at that quick. For task 4. Okay, yeah, sure. I think it's just missing from the image. I'll go update the image later, but it's pretty much just sitting next to the reset button. It's not a particularly complicated addition. But yeah, so no, today we're going to be talking about JavaScript because HTML and CSS are quite straightforward to teach. There's just a lot to it. You know, like, we're like, here's HTML and CSS, and you could spend hundreds of hours learning more about it in your own time, but we give you enough to kind of teach yourself what you need for assignment 1. So from week 2, as you can see, a lot of the week 2 lectures, in fact, basically all of the week 2 lectures are on JavaScript, because fundamentally, JavaScript is the challenging part of this course. It's the thing that's hard to learn. So week 2 is really about JavaScript, which is why today's lecture is about JavaScript. And then as we get into week 3, next week, the lectures to watch there include some basic, what would you say, like some more basic CSS, as well as a bit more JavaScript. And then that's also where we start to go a little bit deeper into React. Because as we've said, because React is part of your third assignment, we like to give you little tastes of it earlier in the course. All right, so there hasn't been any other questions. I mean, Hong Tao says how to use JS Debug. I don't think we do much with JavaScript debugging in this course, mainly just because there's not an extensive amount of JavaScript we deal with. It's all fairly straightforward in the early days, but we might talk about debugging tools later in the course. But basically, the early ways of debugging JavaScript are your standard just print stuff out, right? Like that's how you debug your programs, like in C with printf and Python with print, and in JavaScript with console log. So just using those same kind of debugging habits and principles you've developed to date should be fine for that. Okay, so we're going to get into this lecture. This is a really important lecture for understanding what is happening. So most of what the week 2 lectures are about, and even week 3 on JavaScript, they're actually a lot of like, here's a really practical lesson, here's something you can go do, now you can go and manipulate the DOM, now you can go and create a form, you can go and listen to an event, You can go and store something locally. Like, there's a ton of very practical little snippets of lectures here. Today, though, I really want to take a step back and explain to you how all of these pieces fit together. Because, right, we're going to talk about the JavaScript ecosystem, which are these pieces I'm referring to. And as part of that JavaScript ecosystem, there's all these questions that come to mind when you start dealing with this stuff, such as, like, what even is JavaScript? Is JavaScript what Google Chrome has? Does Google Chrome use JavaScript? Is Google Chrome JavaScript? What is Node.js? Is Node.js the same as Google Chrome? Is Node.js the same as JavaScript? Is it different from JavaScript? Is Node.js part of JavaScript? Like, there's lots of really interesting questions because, you know, compared to a simpler language, most things to do with web have a fairly extensive and complicated stack. There's a lot of components that you need to understand to fit those pieces together in your head. So we're going to take a step back from some of these questions and really talk about fundamentals and the building blocks that actually make your web pages tick, and how everything you're going to learn in this course in terms of JavaScript, which is most of the course, how it all fits together. Okay, so firstly, this is a bit more conceptual, but we need to understand the difference between three key things. And those things are a language definition, right? The first one over there, a compiler or interpreter, and source code or plain text. And you might actually have an intuitive understanding of these without realizing it so far, but it's really important to distinguish between a language and a compiler. And I'm just going to use like C and Python as examples because a number of students in this course have interacted with those languages, right? What happens when you build a programming language that can be compiled is a team of people or a community sit down and they write out the language in a giant document. Now, I haven't looked at the Python one. I've mainly looked at other ones, but it's like, I don't know, Python language definition. It's usually somewhere here. It's not very accessible because it's not really like something that a normal developer would be interested in, because normally like you'd be interested in actual documentation. But somewhere out there's an actual guide, and there'd be another one for C, which really describes the syntax and rules of the language, right? Like, what does an if statement look like? How does indenting work? What are like the relational expressions? What does double equals mean? What does triple equals mean? If you think about the week 2 lecture, which hopefully you've all watched by now, that's the assumption, on JavaScript syntax, the one I recorded, that lecture in a lot of ways is basically just a whole lecture on the language in a sense, right? Like, you're learning about, like, this is what the language does. There's like a class definition, there's these number types, and this is all specified, but it has nothing to do with software. It's purely documentation. And it's like one standard, you know? So like, you know, Python version something is like, Python 3 is like a language standard, and that's the standard. There's not like the American version and the Australian version. It's just like the standard. And if you add new features to a language, typically it's because people modify the language definition and come up with another version, right? Like Python 3, Python 4, Python 5, something like that. This isn't software, that's documents. The second thing that comes in tandem with that that's equally as critical are compilers and interpreters. And what compilers and interpreters do is they basically take source code or plain text, which is literally just a bunch of ASCII characters. That's the code you write. And it reads through that character by character, and based off the language definition, it actually turns it into runnable machine code or something that's able to be executed. Bytecode, machine code, whatever. So a compiler's job is to take source code, produce machine code according to a language definition. Now, because of this, sometimes you can actually have many compilers for the same language as well. This happens a bit in C++, for instance. Like, there are some compilers for Mac, I think, and some compilers for like there's like libc and GCC. There's a few different things, but they're all trying to implement the same standard, right? And this probably makes sense to you. Like, you can have a standard, like what's a good example of a standard? Like a wall socket, where you plug your Australian outlet, your Australian appliance into the outlet. It's like you have one standard. There's not like 5 standards of Australian outlets. There's one, but that doesn't mean there's one manufacturer. Lots of different people have to manufacture and build something to that standard. And some of them might have extra features that aren't even included in the standard that the manufacturer, for instance, thinks is useful. Some of them might implement the standard incorrectly, and there might be something wrong with it or faulty about it that confuses people, because by default, people expect a compiler to compile to the language that defines the compiler. But there is sometimes a lack of connection between the two, but in general, that's the kind of relationship. So then when it comes to JavaScript and stuff, right, and this is just a bit of a summary before we get into the specifics. A compiler or interpreter takes plain text and it produces executable programs, right? And it does that according to the language definition. This is the main crux of this whole slide here is mainly instructional, but this is the real takeaway from it. And when it comes to JavaScript, this is the world we're working with, right? So if I kind of look at the right-hand side up here, you kind of start with your source code, right? That's your actual JavaScript file. And there's a series and that's built with a kind of compiler, which uses a language definition. So same kind of process. But when it comes to JavaScript and compiling or interpreting JavaScript, what are those compilers and what is the language? So the first thing to understand, if we start from the very far side, the language definition, is that the language you code in when you write JavaScript, right? Like that lecture that said JavaScript syntax, the language itself is actually called Ecmascript. Sometimes it's ES for short, like ES for Ecmascript. And it's kind of always been like that. Ecmascript is just the name we give the language that JavaScript essentially implements. And it first appeared in 1997, right? So it's not like a new thing. It's just kind of always, that's what it's always been. Though there are different versions of it, right? Because as you implement, as like communities say, we want our language to be more capable, they add more and more features to it. So as you can see here, there's Ecmascript version 5, which was released in 2009, and then there was ES6, which was released in 2015. And then after 2015, the community's been releasing a language standard on a yearly basis now. And that's why it's now just like Ecmascript 2016, Ecmascript 2017, ES 2018, ES 2019, etc. You can actually go and learn about these language features online. I think W3 Schools has an even more condensed version of this. W3 Schools, Ecmascript. I think they give like a JavaScript versions. The two words are used fairly interchangeably. But yeah, you can see here that like ES1 and ES2, it shows you like what's been added to the language over the years. And you can see that like Ecmascript 3, ES3 in 1999 was pretty trivial. It was capable of, using the new features were regular expressions and the ability to handle exceptions, right? So pretty basic capability. And then you had ES5, which was where JavaScript started to really mature. And it had JSON capabilities built in, which you'll do more of in this course. Some string and array functions built in. And then we had ES6, which is essentially the safe minimum JavaScript version that exists on the internet, right? So we'll come back to that in a sec. But ES6 is kind of like the standard version these days. Standard is in like the base, the absolute worst you'll kind of get. You won't really go much further behind Ecmascript 2015. So that's the language definition. And when you read language definitions, it's quite interesting because they basically, like if I look at, where is it, ES6 or something? That's the end of the article. I read way too fast. Yep, so there's like ES6 and 7, right? They'll say things like, oh, in ES6 you can create a class, and in ES6 you can use modules and importing a bit more Python-like. You can use the, I've never said that word out loud, exponentiation. I know what it means, but exponentiation? I just call it the exponent operator. You can check, if given an array or list, check if an item exists in that list, like needle and haystack. And then more recent versions have even more features. You can kind of read through this in your own time if you're really interested. Like object destructuring, again, for anyone who's worked with Python, object destructuring is super powerful. And it's as part of ES whatever, I'm not sure, ES9. So that's the language definition. Now, where things get interesting is that the compiler, or in the case of JavaScript, the interpreter, is really made up of two key components that need to be understood. And the first component is the Ecmascript Engine. This is the thing that actually does the stuff with the language. Think of it like it's a little bit like the core operating system in a way. Like, has all the basic features. It does things like deals with if statements and for loops and all those basic features. But when we think about a JavaScript interpreter, we'll typically refer to them as runtime environments. Now, a runtime environment of JavaScript is something like Google Chrome, Safari, Firefox, Node.js, these things that are able to kind of run JavaScript in a meaningful way. But these runtime environments are actually built on top of these engines, these Ecmascript engines, which are actually what does the ES language interpretations, right? So you think about something like a web browser. A web browser has the ability for JavaScript to actually store cookies on your computer, right? That's part of the runtime environment, but the actual Ecmascript engine is the thing that deals with the data types and for loops and if statements and syntaxes and arrays. Like, it actually does the thinking. So that's what the engine is. The engine's the real brain of it, and then people build a runtime environment around it. And that source code is executed on a runtime environment. So again, JavaScript refers to a runtime environment that is built on top of an Ecmascript engine. Now, in practice, let's look at some, more practical examples of this. We said we have a runtime environment that runs on an Ecmascript engine that implements an Ecmascript. Well, it implements a language. That should just say Ecmascript. But it's the language definition of the scripting language. And you can see, we have ES 2009, ES 15, ES 17, and these are all different language definitions, which, as you go down, there are typically more and more features. And then the engines that implement that, a couple of them here are Google V8 and JS Core Nitro. And there's a whole list of them here that we could look through if we'd like to. But these engines power different runtime environments, right? So Google has a JavaScript engine called the V8, which is part of the Chromium project, and it powers Node.js, which we're going to talk about. It powers Google Chrome. It powers Firefox, right? Like, when you are using your browsers there, that browser implements the Google V8 engine that takes all that JavaScript and actually does the brain on it. Whereas some other browsers like Safari, I'm pretty sure from memory, use the JavaScript Core or the Nitro engine, right? Which I think is developed by Apple, or at least it's Apple supported. But again, they're all trying to work off the same standards. So let's say that Ecmascript or ES 2019 is the latest, suitable, like the latest stable release. Then it's like all of these engines, like Google's V8 and Safari and the Nitro, will try and implement the new language features, which all these browsers and other runtime environments like to use. And there's more layers to this stack. This is a little bit simplified. Like, between V8, Google Chrome, you might have heard of things like WebKit, which I believe Firefox. I don't know. That gets a bit complicated because they're rendering engines as well to do with browsers. But short story, runtime environments are typically what you actually use. Ecmascript engines are what actually, does the churning. It's the machine that actually processes the JavaScript and makes it happen. And then they're all trying to implement a language definition based on a particular ES version. And again, just remember, each version of a runtime environment like Google Chrome is built off a particular version of an engine. right? So Google might update their V8 engine from version 8.8 to 8.9, and therefore Google Chrome might have to update their stuff from might have to update their version to use the new V8 engine. And then similarly, each version of the Ecmascript engine is built to a particular version of Ecmascript, right? So Google V8 itself would have many different versions, and when there's like Ecmascript 2021, they will, you know, put out more releases and stuff. So there's a certain you know, interconnectivity here when these different components are all trying to update and be up to scratch with each other. Hong Tao's asked, so is Ecmascript downward compatible? Yeah, so if you have, as far as I know, like if you have Ecmascript 2015 code, it can run in the later versions for sure. Like you could have written JavaScript in 2008 that I'm pretty sure will run in the browser fine. I don't think there's a ton in JavaScript that's been deprecated, so most of it should be pretty backwards compatible, but there probably would be one thing or two. A lot of the times when they release new versions, they'll try and keep the old syntax features there for as long as they can, typically years and years, so that it doesn't break the internet, right? Yeah, any questions about this so far? I'm just going to shut the blinds, get in the afternoon sun. So have a think for 15 seconds and tell me if you have any questions. Yeah, you're quiet, don't care. Good to hear. Super exciting, great. Okay. I'm just gonna get my stupid head up here. It's kind of in the way. I wonder who would modify the language definition. That's a good question, Patrick. So, like, the weirdest thing about computer science is that a lot of it's held up by just these communities. And when I say communities, like, who does that mean? Well, it's like, a lot of the time it's sometimes like retired or passionate software engineers, people who helped build it in the early days, a lot of time spent from big tech companies, right? Like, you'd find Google has its hands on many things. Like, most of these languages are kind of inadvertently funded by Google and these other big techs, right? Like, the V8 engine is built by Google. Chrome is built by Google. I think Firefox is mainly funded by Google. Safari and Nitro, right? Apple's pretty much nearly the wealthiest company in the world. But the communities, that they can often just be as simple as lots of little people that work at tech companies all around the world. It's surprisingly kumbaya-like, which is kind of sweet. So, yeah. They'll kind of get together and they'll have debates and processes involved, and they'll put a lot of suggestions in, but only some will get accepted. Sibo says, is whatever funny behaviors mentioned in the WTF.js talk have been fixed? Have they been fixed? Not a ton. So the thing about the JavaScript language itself is that it's a bit of a broken language that good programming patterns have tried to make better, right? So if you know how to write JavaScript properly and how to avoid the bad parts of JavaScript or the pitfalls, it's actually like a pretty clean language all around. The problem is that it enables you to do some bad things, like the double equals and stuff that was talked about in the syntax lecture. You know, those things, they're bad, and JavaScript allows you to do that, whereas you can't do that in other languages like Python. So I'd say there's still a lot of quirks floating around, definitely. Okay, so we're going to have a look now at a few key parts of this. So the ones I've highlighted in blue are the ones we're interested in this course. The first one's the Google V8 engine. I've kind of referenced this a few times. It is an open source JavaScript engine. That means that like open source as in it's free to use. So like you could go onto the internet somewhere. I've never tried to do it. And actually download the source code for the JavaScript V8 engine and compile it yourself. Not that you would find much value in that, but you could do it. It's not just like you compile your own thing and you can run code on it. You'd have to do a lot more than that. But the idea is it's a base component that you can then go and apply to a bunch of other applications. So there's a line here which is that it can run standalone. Basically, it can take in JavaScript syntax and process it, or it can be embedded and extended into any C++ application. And like a good example of that would be, Google Chrome and Firefox. I don't know what they're written in. I'm sure it's probably C++. What programming language is Chrome written in? Let's see. Yep. Okay, so it's written in a lot of C++. That's what you'd expect. You generally expect a lot of C++ is not a extremely commonly used language, but it would be used for a lot of high use or high performance applications. Like browsers are things that need to run very efficiently, because the web's already slow enough without the browser being slow. So the point of this is that like someone comes along and they say, I want to build Google Chrome, and if you were writing some kind of C++ application, you would basically be importing and using the Google's V8 engine. Right, so if you would imagine you're building Chrome, V8 Engine is like a library that you can use to actually execute code. Now you can see here that what V8's capable of is it takes in source code. If you're not familiar with compilers, some of the stuff will go over your head a bit, but it's like it takes in source code, it parses it, which is basically, it reads it, it breaks it into an abstract symbol tree. I think it's called an abstract symbol tree. Probably got that wrong. Yeah, in syntax tree, symbol tree, abstract syntax tree, which is your standard kind of compilation thing where instead of your code just being a bunch of text, it actually breaks it up into a structure like this that it can follow. So it turns your code into a tree. There's a great compilers courses in CSE. I don't know what it's called because they change the names all the time, but go do that. It's super cool. And then from that, it's actually able to generate it into something that can be run, right? So then it just starts running the darn code, and doing the instructions, the additions, the subtractions, the looping, everything like that. It's very simple. It doesn't have APIs. It doesn't do input-output. It can't open files, read from files, make network requests. This is purely something to actually like run JavaScript. And like, I think, if you think about your days in programming C, for those who program C, if you don't import stuff into C, it's a pretty straightforward language, right? It's very core and basic. And if you're struggling to conceptualize it, it's kind of like that. It's the most basic kind of thing, ready to be expanded upon. And two of the main ways that it's expanded upon... Oh no, I've got the wrong diagram there. Let me go and hunt down the right one for you. So... two of the basic ways that it's been expanded upon are Node.js and Google Chrome. And Node.js has, it's still this slide here. Node.js has a somewhat interesting architecture, which you can see here, where, actually I should talk about what Node.js is first, sorry, that's probably confusing. So Node.js is a runtime environment, right? Which means it's built for people to use. That's built on V8 and it's typically interacted with via command line, right? So this is where, if you've seen the lectures or you've started to do some of the work, you can actually interact with JavaScript on command line. The best analogy I can give to people who don't know what that means is, how with Python, you can just write Python, import modules with Python, run Python on the command line, and it does stuff. Node.js is the same thing, but for the V8 engine, right? So the V8 engine just interprets syntax, but Node.js is what allows it to be on command line, have modules, import things, actually run it, and do a few more interesting things. All right, so again, V8 only provides the core parsing and compiling, but features that you want to use with JavaScript, like network requests and input-output to like open and close files, the ability to include other modules. That's all built with Node.js on top. So if we look at the architecture here of Node.js, you can see that the actual application itself uses the V8 engine, right, to run, but it expands the V8 engine by connecting more to it, right? So it's like the V8 engine with bonus features. And some of those bonus features are things like asynchronous code, like an event loop, which if you go see, I think it might be week 2, I have a feeling it's 2. Week 3, damn it, okay. There's a week 3 lecture that Anna does on events, which is super exciting. But also network requests, right? Like calling a URL and opening and closing a file, reading the system time. Like these are all things that V8 can't do. Node.js has to actually extend that for them. Logan asked a little while ago, is VS Code a runtime environment? No. VS Code is not a runtime environment. It's an IDE. It's a very advanced text editor with a lot of good integrations. VS Code, though, does have a terminal that you can use in it where you can run a JavaScript runtime environment like Node.js. Or if you were to connect some Node.js add-ons, I'm sure there's some ways that you could run your code without needing a terminal, because clicking play buttons and other things would essentially just execute Node.js commands on the command line for you in the background. So that's the architecture of Node.js. V8 extended to be more useful than just something that reads source code and does actions. Then we have Google Chrome, a lot more complicated, but that's not to do with the JavaScript part. So any web browser. A web browser is basically an HTML and CSS document renderer. So what you're doing with assignment 1, where you're just kind of given, you're like, oh, okay, I'm going to write some HTML and CSS and make a web page look a certain way. That is that's the main purpose of a web browser. A web browser is like JavaScript is a secondary thought classically to a web browser. Web browsers are for rendering pages. Web browsers started to integrate runtime environments. Web browsers started to integrate, these Ecmascript engines like V8 into them so that they can actually process JavaScript. And if you have a look at the what would you call it, diagram here, you can see that V8 is just a part of the browser. A lot of the browser is actually rendering a page. It's some other things that it implements itself, just like Node.js does, like an event loop or event queue to kind of keep track of events, because, JavaScript's an event-driven language. You'll learn more about that in week 3. I have the hiccups. You have something to parse HTML, and then there's also other APIs that are built on top of it so that your web browser can actually do things like, make network requests and fetch images and store cookies and store other types of storage on your browser. So the JavaScript V8 engine is a small but critical part of a web browser that allows for the execution of JavaScript, and its purpose, as I said, pretty much persist data client side, so cookies, local storage. Can't remember what the other types of persistence are off the top of my head. Make network requests and mutate the DOM. And by the DOM, again, that's a week 2 lecture, which is essentially talking about what is a web page, right? Because a web page is more than just HTML and CSS. The browser actually keeps a model of it stored, right? So you should, again, have probably seen that lecture by now, but if you haven't, browser keeps a model of things, and JavaScript allows for the modification of that model, because that's fundamentally what we use JavaScript on web browsers for. We can build static pages with HTML and CSS, and we use JavaScript to modify those pages in a dynamic way. That's what brings them to life, right? HTML makes a page, CSS makes it pretty, and JavaScript brings it to life. Someone's asked in the chat, what was the runtime again? So, the runtime environments are things like Node.js. They are things like Google Chrome and Firefox. They are what like typically you use. Those runtime environments are powered by the Ecmascript engine, which implements the Ecmascript language. And then we'll get on to managing packages in a sec. So I talked about this briefly in my tutorial recording this week, but I think we could probably even look back at Tut 2, wherever it is. So I have to look at the solutions, sorry. Give me a sec. Tutorials, Tut 2. Yeah, okay. So here's the thing I just want to step through. So here's a piece of Node.js code. Now before we really get into that Node.js code, let's talk about Node.js. It's easy as hell to install. There's a guide for it on WebCMS3 in the sidebar. But in general, it's also installed on the CSE machines. And you can run Node.js just by like you can with Python. Like I can write Python 3 and I can start writing Python, right? Like a equals 1, print a plus 1, and I get 2, right? Print a plus 1, I get 2. A plus equals 2, print a plus 1, I get 4. I can also write a Python file and run it by typing in, Python 3 and then giving it the file. Similarly, I can do the same thing with Node. I could say Node, and then I could say let a equal 1. A plus equals 2, console log a plus 2, which should give me 5, right? So that's just me writing out JavaScript. Now, I could do this exact same thing in the web browser, or I could do this in the command line, and I'll show you here, right? If I have like code.js and I just say let a equals 1, a plus equals 2, console log a plus 2, I'll get 5, right? Very simple file. Node code. Damn it, node code. Yep. Now, let's try and run that in the browser. So, I'm going to create a new file here. I'll just create it in lectures. Give me a sec. Just call it browser.js. Okay, so we have a really simple file here, and let me just open that one up in the browser in a new tab as well. I just have to find it quickly. So I've lost everything today. Lectures, okay, browser.js. So this is the file. Can I open it up here? New file? Yep. So it's an empty file. But here's the thing. If I copy and paste this JavaScript, right, code.js, and I just put it in a simple page here with even just the script tags and nothing else. And this shouldn't be called browser.js. Damn it, it should be called browser.html because browsers run HTML pages. They don't like run JavaScript pages. Great. Browser.html. Nothing prints because nothing prints because we're not actually rendering anything on the page. But what we are doing is we are console logging. Now, when you're using a terminal, console logs get put on the terminal. When you're using a browser, the console logs get put on the console tab over here, if you haven't seen that already. So when I run this page, it works because what I'm doing here is not really like that complicated. It's just using JavaScript's basic features, which the V8 engine is more than comfortable doing because it's so simple. However, there are different things that happen on the browser and on the command line. So if you look at the week 2 tutorial, for instance, there was this question which has a solution which your tutors, you can see it in the the recording. But if I open code.js and I paste this in here, this won't work because this data.txt file doesn't exist. However, was my head blocking the console? Oh, sorry. I see now. Oh, it's okay. The 5's there. That's actually all there was. Thankfully. There's like nothing else. It's just a 5. So that's fine. It wasn't very complicated. So this runs, right? I'll get an error, but it's just a runtime error. It'll just say it can't open the file. But it actually runs because Node.js is very comfortable importing a file, which is built into Node.js, and reading from disk, which is built into Node.js. And then the rest of this here is kind of core JavaScript, right? So like a lot of this is just processed on the V8 engine, which is implementing Ecmascript. And then this part is that extended stuff off of the V8 engine, which Node.js kind of wraps around it to have some extra features. On the browser, on the other hand, if I was to paste that code in here, we run into this problem where the browser will be like, sorry, I don't know what require is. And that's because require is not like, it's not JavaScript in the sense that, it's not JavaScript in the Ecmascript sense, right? I think I forgot to say before, but when people say JavaScript, the word JavaScript is kind of just means the implementation of Ecmascript. It's really weird because like when you write JavaScript, you're actually just writing like Ecmascript, like that's the language you're writing, but JavaScript's kind of the term people use for it. I think more formally it refers to the interpreters and the runtime environments and stuff itself, like the engine, but this doesn't work in the browser because require is not defined, and there's a whole bunch of other things that work with Node.js that don't work in the browser. And on the flip side, there's things that work in the browser that don't work in Node.js, right? So in the browser, I have two pretty standard properties, which is document and window, right? You'll use these, mainly document, a lot more in the course. And they're huge properties. And document, you can see, it's actually just the HTML page. Like, document is the DOM that is mentioned in the DOM lecture. It's just where everything is. That makes sense in the web browser because when the runtime environment of the web browser wanted to extend the V8 engine, it was like, well, V8 will do all the JavaScript processing for me, but how do I actually create an interface for it where people can, manipulate the DOM and work with the file system and stuff? So this all works fine, but again, if I take this and I put this in like my code file and I try and just, console log these two properties, what happens? It says document is not defined, right? Because it's the runtime environment of Google Chrome that is populating and extending V8 to have that capability, right? This lecture will end 8 p.m. No, I don't think it'll take that long, but it's not ending at 7. Yeah. Okay, so quick pause to look at some questions. Devansh says, do you recommend using use strict for assignments and everything? You can if you want. I don't think that, like, I don't think we're going to be anal retentive about using use strict. You will get generally marked on style, but that'll be a little more high level. What I would say though is that whether you use strict, which I don't really use ever, which we'll probably kind of get to that because normally you'll just use linters and things for that. Whether you use it or not, it's usually in your best interest to write good JavaScript anyway, because good JavaScript means it stops you. JavaScript's a tricky language, so if you don't write it right, then it can make it pretty hard for you to get things working when you get spaghetti code pretty quick. Where are we? Yep, so that's a browser. That's Node.js. So browsers, like, we talk about that more and more in the course, and a lot of the JavaScript you do will be done on browsers in this course. You don't really do much Node.js in this course. Or, like, yeah, you don't really write much Node.js. You use Node.js, but I guess you don't, in this course, you don't write a ton of things using Node.js's features. Whereas, like, a lot of the browser things that extend V8, like, you know, interactions with the DOM and persistence and networking, you will do a lot of that in the course. So yeah, good fun. Let's talk about Node.js though. I guess just before that, we should probably check if people have questions. We also might take an early break after those questions, just because once we get into this, we'll probably go for a little bit again. So yeah, any questions so far? Super exciting. Okay. Well, in that case, before we jump into Node.js and NPM and stuff, and transpilation, let's take just like a 5-10 minute break now, and we'll start back up just around 7, and we'll keep talking about Node and NPM, and we'll also talk a little bit about what transpilation is, which is kind of the last piece of understanding this JavaScript environment. So yeah, 5 to 10 minutes. Chat soon. So there was one question two questions over the break. First one's Patrick. So Patrick said, so is JavaScript a broad concept? It behaves differently in different environments. Like it would interpret differently in Node.js versus web browser. You ask, why don't they become standardized? And I mean, the answer is they are standardized. The thing is, though, that most things are standardized. Even the things you think are standardized, but doesn't mean they're perfect, right? Like many compilers have different implementations, right? Some don't, but some do, and they work differently on different systems. The main point is that JavaScript, the language, is standardized. It's clear what it should and should not do and how it should and should not behave. But you know, some runtime environments offer different extra features, right? Because they're there for different purposes. And Zenji's asked, there is a merge request message in GitLab about assignment 1. Should we do something? Yes, that's a great question. Zenji, do you mind if I pull up your repo? I won't show your code, but I can show like the merge request, and I can show everyone what to do. If you're okay with that. If not, that's fine. I'm okay with that as well. Good old YouTube lag, waiting 5 or 10 seconds for everything. It's okay, I'll just move on. So I'll come back to that question then about assignment 1. So Node.js managing packages. Now, here's the thing about Node.js. I mentioned earlier that it has a sense of modules, right? A little bit like Python, how Python has modules. Rather than just being a single file you can write JavaScript in, you can actually import lots of modules that do different things. So as an example, you know, top 10 Node.js modules. Yeah, I know you can just merge them in. I want to be able to show someone in the lecture. So if anyone wants to if anyone hasn't merged in the merge request and wants to volunteer me just to pull up your stuff, not your code, just your repo. I don't need your code, then that would be helpful. So here's a bunch of Node.js modules. Express, which helps you build web servers. Socket.io, which helps you make WebSocket connections. Body Parser, which helps you parse, you know, bodies of HTTP requests. Cores, which is another web server thing. Passport, which is about authentication. I don't know what Malta or Morgan is. And Axios, which is a way to make network requests. Cool. Thanks, Yasmin and Sibo. I might grab Sibo's just because I got a ZID there, but thank you both. Now, when it comes to Node.js, if I make a new folder here, and I'll call it my project, I'm going to assume that a number of you are quite familiar with Python, and you know that in Python, you don't just use the Python 3 command, you also actually have the pip library, right? Which is how you install stuff with Python, right? Pip3 install such and such. It's how you manage packages. And in Node.js, we actually have a similar package manager called Npm. Npm is like kind of the most common Node packager for Node stuff, and it is a package manager and package installer built off of Node.js. So essentially, whenever you have a Node-based project, you will typically use npm or something else to manage it. And when I say manage it, I usually mean that how to put it? It's like there's lots more to Node.js that we talk about a little later in the course, but at the basic level, it's managing in terms of keeping track of all the dependencies that are used. So I'll give you an example. If I would, I mean, I already did this npm lecture on this, so I don't want to go into it much here, but you can go watch that. But the crux of it is you can create like a little project. This is your way of saying I want to create a Node.js project. And then inside of that, we now have a file, a package.json. And when I add stuff with npm install, like I might try and install Express here, for instance, and I install that, it will install it, right? It'll actually go through the motions and it'll install it. And when I ls, you'll see here that there's a Node modules folder where it's actually stored now. That's where all the installations happen. And then I've also, if I open package.json, you'll see that npm actually added more lines to this, and there's this new section called dependencies here with Express here. So this is how it keeps track of it. Again, if you're familiar with pip3 and requirements.txt and virtual environments, it's all the same except a hell of a lot easier than the way that Python does it for reasons I won't understand. So that's really it. And if you're doing this as part of a Git repository, then the package.json is what you store in your Git repository, not the Node modules, because it's really just the instructions to install. And if you want to install everything inside of your package.json, you just run, you just run npm install, and what that will do is it will look for the package.json and install everything in that directory. Now again, I did a lecture on this, so I'm just rehashing this for continuity, but it's already there and you can go look at it elsewhere. The two things I want to flag though are that there are two other types of package managers, which is yarn and pnpm. Now, they all do roughly the same thing, and they all use Node modules. They all use package.json roughly. So, generally the only main difference between them is the commands they use and some internal workings. For instance, yarn is quicker to do installations because it does some things in parallel. pnpm has a lot of features around network caching. So, like, one common problems at companies is that if you have like 200 staff members who are all npm installing modules, that's like can be gigabytes, like hundreds of gigabytes of stuff just floating around all the time. So and it takes a while too. Like if you ever try an npm install in a large Node.js project, it actually like can take minutes and minutes and minutes. So pnpm has some extra features to do with like shared drives where you can like, for many projects, you can like have a cache where instead of pulling from the internet, you can actually pull from a common cache, and it has some other fancy things. But generally, npm is probably, I think, most widely used. I mean, we can have a look at it, pnpm usage, and there's probably more than that since then. I don't really know how to tell how much they're used, and most of the charts will probably be outdated. When is this taken? It's not going to tell me much interesting. This article, 2018. So, I mean, you can see here that, npm and yarn are kind of used pretty commonly. One big reason yarn is used a lot. Remember, so when I say yarn, it's basically the same as npm. It just has different commands. One reason Yarn's used a lot is because it's the default package manager for React JS projects, which is a way of building front ends that's in this course. NPM is kind of like the grandfather in a way of this. Like NPM was the first package manager with Node as far as I'm aware. So that's kind of why, it's still very common, even though I guess most people would argue it's maybe not as good as Yarn. Generally in this course, NPM is like what we will talk about unless it comes to React.js projects, in which case we'll be doing Yarn stuff. But you can go watch that other lecture on it. And you only use one of these package managers per project. It really doesn't matter which one you choose, whether you use Yarn or NPM or PNPM, but the point is that for a project, you should stick with one. So if you start a project with NPM, you should continue to use NPM for it. You can migrate it, but it's more painful. But my point is, you don't go and install something with NPM and then uninstall it with Yarn or anything like that. That's just a bit weird. And then the last thing about NPM is the difference between NPM and NPX. Now, in the week 2 exercises, or I can't remember exactly where it is, we get you to build a very basic React app. We want you to start practicing with it. And you come across this command called npx. Now, what npx does as a command is it actually npm downloads a particular JavaScript, a Node.js module, and then it immediately tries to run it as an executable. So there's some modules, most modules in fact, in JavaScript, like Express and this and that are libraries, right? They are there to just be imported into projects. For those who are familiar with Python, because I know there's a large number of students here who've used Python before. Something like JSON, for instance, as a library is something you would import, whereas, to contrast that, something like in Python Flask or like PyTest, they are things that are executable, right? You actually install these modules to execute them. And when it comes to Node.js, it's a very similar thing where we have these libraries here which are all actual libraries that you don't want to execute, but there are some libraries like npm create react app, which again is in one of your tutes and exercises, which is an actual npm library that is executable. And what that means is you actually want to execute it. So if there's a Node.js or an npm whatever module that you want to run as an executable, instead of doing npm something, you just do npx, which is kind of like node package executable, and then you do create react app, and that will first download the module. You'll see it here. This is it. This is it downloading right here. And then once it's downloaded, it'll start running it as an executable. Because I haven't given it the commands, I don't think it'll do anything. Yep, so you can see there, that was it. It installed it, took 10 seconds to install, and then it tried to run it, and it didn't run because it basically said that I haven't invoked the command line. I haven't done the command line arguments properly here, so it didn't actually invoke the process properly. It quit early. Yeah, so we don't use npx much, but hopefully that gives some context over what it actually is and what it's actually doing. And honestly, the only place you'll probably use it in the course is with Create React App. That's pretty much going to be it. Let's take a quick pause. So these merge requests, I'll just quickly explain this to you. So in a normal course, when you update an assignment spec, when you update an assignment spec in a normal course, it's kind of annoying because you basically just update this HTML file and then you email the students and you tell them that the file's been updated, and then they don't know what was updated and sometimes they lose track of it. But the way we do things here with COMP6080 is that when we have to clarify something, basically whenever we update the spec, what happens is that we send a merge request, which is here on the left-hand side in GitLab. And basically this is us saying that we have some updates for you that you have to accept and merge in. I might change this so that it automatically merges it in for you. But if you see anything here, this is essentially us pushing updates to your project. Now, any updates we push that you don't get an email about are minor in the sense that they're not going to tectonically shift your work. And in this case, we made one which you can see here, which says, added a font size section under analyzing pages to clarify how to interpret the best font size, which basically just was a very long-winded way of me writing, do your best to figure it out. Guessing and tweaking as part of this assignment, right? Like, that's not critical information that, so that's why we don't send out an email about it, but you'll see that appear in your repo. That's how we just make little tweaks and stuff, little clarifications. So you can merge that into your repository. I know this might seem a little bit unnatural to those that haven't done this before. You'd be like, oh my God, that's like really confusing. But it's actually really handy because it means that you can kind of dissect a lot easier things like I just showed you. It's really easy to tell what's happened. And also sometimes we might give you assignments with starter code, for instance. And that starter code might need updating. So rather than sending you an email being like, open this file and remove these lines and replace them, we can just say, we'll update it for you. Really easy stuff. Okay. Last topic, transpilation. So what the hell is React.js? Well, there's a lecture on it. Again, hopefully you've seen the first lecture, which is the intro to it, which is basically like, it's really not much. Very, very basic. And we're not getting into like how to build stuff or whatever. I more just want to explain conceptually how this fits into that ecosystem I was describing before. So React.js is a JavaScript-like language that builds code into standard Ecmascript compliant source code that is executed normally on a browser. What does that mean? Well, React.js is written in a kind of JavaScript. It's written in React, right? But React is kind of like JavaScript with bonus features. But the point is that when React builds, like compiles, GCC, whatever, it builds it into JavaScript, like normal JavaScript. So this JavaScript we were writing before is what I'm referring to as normal JavaScript. Very simple, very basic. It uses standard language features to accomplish goals. Whereas React.js is like, if I look like Google React.js code, and if you haven't seen the lecture, it all just looks a little bit weird, right? Kind of looks a bit like HTML, kind of looks a bit like JavaScript, looks like there's some fancy features in there. What React.js does is when it builds or compiles, it converts that to boring old JavaScript, which touches on a really important point. Learn more about React.js in the lectures. But about the difference between compiling and transpiling, right? Compiling, it's funny emphasizing it like that, it's just called compiling, but compiling is a broad term that is used to describe what happens when you take the source code written in one language and you typically output it in another language that tends to be low level. And typically that's machine code, right? So when you compile C or C++ or Java or whatever, you're essentially taking source code that's written in ASCII, right? That's the input, it's just text, and you're outputting it in a format that like typically a processor of some sort or some layer above that can actually process. Transpiling, though, is a very strange concept if you haven't come across it, which is the process of taking source code written in one language and outputting source code written in the same language, right? And you might think, why would I have a transpiler that takes in Python and its output is Python, not like executable code? And the main reason is versioning. Right. Versioning, like one reason is versioning, the other reason is because well, let's talk about versioning second. React.js is technically JavaScript, right? That's what makes it transpiling. In reality, though, when you code in it, this here does not feel like what I had up before, right? They feel like different languages. So in effect, it seems like it's compiling. It seems like you're using a very high-level language and you are converting it into something simpler. But in actual fact, it is transpiling because, weirdly enough, this is actually a form of JavaScript here. So in some senses, like, React transpiles to normal JavaScript because React is JavaScript, but you can kind of think of it like compiling. The second reason, though, which I mentioned, which is versioning, is often about backwards compatibility. And Logan has said in the chat, quote, like from Python 3 to Python 2. And yeah, exactly right. So as you know, like, some really old computers might not be able to support Python 3, right? Python has like the 20-year supported version, Python 2 or something. I don't know how long. And then Python 3, which has really come along in the last 5 or so years. And if you write some Python 3 code and you want that code to work on like an old operating system that just isn't able to get that new version of Python 3, you might be able to transpile that, which would be basically, yeah, exactly. You can basically transpile that and convert Python 3 to Python 2. So the transpiler takes in Python 3 code and it outputs Python 2 code. Later on, that Python 2 code would have to be compiled or interpreted, like compiled at runtime, and turned into machine instructions to actually be processed. And that's a very similar thing to what we do with JavaScript, where JavaScript kind of has a compiler, which is the V8 engine, which is capable of taking source code and turning it into machine code or executable code. And a transpiler will convert new JavaScript to old JavaScript, or it will convert React.js to like old JavaScript. So React.js is actually essentially, like, the simplest way to think about React.js is that, at least this early on in the course, right? Why don't you like to write everything in C? It's because it's miserable, right? It takes so long to do basic things. So you like to write in a language like Python. Even though Python and C kind of just compile to the same thing eventually, mostly. No, not literally, but, you know, they both compile to machine code, and Python's a little slower, but it's so much easier to work with, so that's why we like it. It's a similar thing where you can write JavaScript. You could build entire websites in JavaScript, like the JavaScript you've seen us write, or in the Chute, for instance, like, you know, this kind of stuff here. You could write entire websites like that. I've done it, tons of people do it, but it's kind of miserable because there are more powerful tools there that are higher level, like React.js, and similar ones that you can write in, but instead of it compiling directly to machine code, it transpiles to JavaScript and then compiles to machine code, right? So it still actually has to go through JavaScript. And this will make more sense in a sec. So how do we actually transpile it, though, is the next big question. So React.js transpiles to ES5 compliant JavaScript, and a lot of ES6 or greater JavaScript transpiles to ES5 compliant JavaScript. Why ES5, right? Well, I mean, it doesn't have to be ES5. It could be ES6. You could transpile ES7 to ES6. You could transpile lots of things to lots of things. But ES5, which was the 2009 release of Ecmascript, which pretty much is a while ago now, is virtually supported by every web browser on the internet, right? So most web browsers would, like most standard Google Chromes and stuff, would implement really new versions of Ecmascript. I don't really know what one my Chrome would be. It's probably like, I don't know, version 8 or 9, just like yours. But old browsers don't always do that, right? Old browsers might, they might be running Windows XP, which hasn't really got some kind of upgrade because maybe Firefox or Chrome stopped supporting it. Maybe people are using an Internet Explorer. Maybe people are, you know, running systems at work where the system admin has simply not done it up. Like, there's so many reasons people might be running old browsers. So Ecmascript 5 is generally considered like the safe 99.99999% of all web interactions are at least at that level. So therefore, if you take a newer version of JavaScript or React.js and you compile it to that level, it means that it's pretty much going to work on every web browser, which is super useful. So we use tools to transpile, and I'll give you a really good example, right? So Babel is a, well, how would they describe themselves? They have like an about or something. Maybe I'll just look at the Wikipedia page. I like to use their definitions because Babel, was that it down there? No. Babel Transpiler. Well. Oh, there you go. Transcompiler. Babel is a free and open source JavaScript transcompiler that is mainly used to convert ES6 and higher code into a backwards compatible version of JavaScript that can be run by older JavaScript engines. It's a popular tool for using the newest features of the JavaScript programming language. So there's a reason this applies mainly to web browsers, right? And the reason is because web browsers, when you build an application for a user, you're sending it to like all the web browsers on the internet, right? But when you write something for Node.js on your computer, you can generally control the version. Do you know what I mean? Like when you write some Python or C code, you tend to run it like on your computer as if your computer's a server. So you don't really have issues where you write like Python code and you're like sending it to 1 million people hoping, oh God, I hope they have Python 3 or something like that. That doesn't really happen with Node.js. So this transpilation is not as big a deal when it comes to writing Node.js stuff. It's more a bigger deal when it comes to building web pages. Because you release a web page and anyone in the world can get access to it. So Babel does that. Now, let's have a look at a really basic... oh, there you go. Let's think about some ES6 features, right? If I have or ES7 or something. If I have an object in JavaScript and, it's kind of like a dictionary and it is like, name is Hayden and age is 4. This transpiles to a JavaScript compatible code pretty much the same because this JavaScript made sense a while ago, right? Const, I assume, I don't know when const was introduced, Ecmascript const. I don't know when it was, what it was part of. I don't know if it's going to tell me. Looks like ES6. So I don't know. I don't know what this Babel editor is doing because like it's very custom. Like maybe it's only going to ES6. I'm not sure. But let me show you a new language feature, which I think is like, is it object.values? Is this one of them? Will this transpile? No, this one is older. This one is newer. Okay, it's probably converting it to ES6, but let's use an ES7 feature, which is if you have a function that's like, what would you say? Like, so if I make a function in JavaScript that's like print stuff, and it's going to take in a name, like a first name and a last name, right? And it's just going to console log first name, last name. Simple enough. In I think ES7 they introduce, or ES8 they introduce what's called the spread operator, which does exist in other languages too. Where so here's the thing: if I have a list like const name equals Hayden Smith like this, if I want to pass that into a function, right? Like if I want to call that console. I want to call print stuff. To pass that in, I have to say name 0, name 1, right? Because I've got a list with 2 items and I have to pass in Hayden as the first argument and Smith as the second argument. Whereas if I want to just basically take a list and say, here, I'm going to give you a list, but I want you to expand that list out into the arguments, then that's when we use a spread operator like this. My God, why is this? What the hell version am I working with here? Probably using the wrong thing. What version? I don't really use this directly much. Lord. I don't know. I don't know how to change I don't know how to use their online tool to change the Ecmascript version. So weird. There you go. The things you learn. Which isn't much. Maybe they've upgraded it since I used it in T3. I'm not sure. That's a shame. I was really looking forward to showing that example. What was it? Babel online to ES5. We'll find it pretty quick, hopefully. That's the same damn thing. Babel ES5. What will this do? Let's try this one out. Run. Enter. Run. Enter. So weird. I think it shows the version in the bottom left corner, someone said. Someone's coming to save me. Where's that? There's no version there. It's okay. I don't know. Oh well. I don't want to waste your time on this anymore. The main point is that JavaScript didn't really have this spread operator back then. So they pretty much just had to... Hey! I did it. Okay. I'm not sure what this transformed what to, but that's okay. This is an example of transpilation where some earlier... I was actually just trying to run it before to see if it broke, to show you that this is not like ES5, ES6 compatible. But yeah, sorry, compiler Babel. This is a transpiler. I'm an idiot, not a compiler. So these are actually like, it says compiler, but these are essentially transpilation tools like Babel version 6, Babel 5. You can see if I use a different thing. See if I use like ES 2016 that it does it fine, right? It's like these are all now native language features. If I do ES 2015 now, it's like, oh, that's not so fine, right? Because ES 2015 is ES 6. So I've used some ES 6 features here. So I've used some ES 7 or higher features here that have to be transpiled. And you can see the two ones that matter are this equal arrow syntax, which didn't always exist in JavaScript, right? But this is a pretty standard approach. You can also see that they've replaced const with var, right? Because const was also added later. And then this spread operator here, they've done something kind of funny, which is like a... there was like an old JavaScript feature where you could say the function .apply, and then you could essentially like give it a list and it would apply the elements in that list as arguments to that function. But the point is, like, this is just some weird, like, this is a really simple example, but this is what transpilation is at the core of it. So again, the two reasons for transpilation are to convert things like ES, like newer version of Ecmascript to older ones, or to transpile React stuff, which is the last example we'll go through. So even if you were building a website, not that we expect you to do this in this course, but even if you were building a website using plain old JavaScript, you would still try and transpile it, because there would be a lot of browsers out there that would not natively understand this. And like, you don't, it's not that scary, right? Like my browser will, no doubt. I'll just plug that in there and I'll go load up my web page, and my browser will be like, there you go, easy. That wasn't so hard. But that's because we're all running, you know, standard operating systems that are getting regular updates, and we're using pretty like modern browsers and everything else. So okay, so the last thing is just to quickly talk about React.js transpilation. And I'm just going to quickly, this is all in the React lecture, so that's why I'm glossing through it, but I'll just quickly like create myself a React app called like week 2. This will take a minute. So let's just sit back. I'm going to pause the recording at least while we wait. Yeah, so the React's now... Sorry, just to recap. We've just installed the React app, right? It's really basic. We're now running it. This is like how you can develop with it. This is in the React lecture. So I'm not going to rehash it again, but I'm just like continuity. Load that up. It's really slow compared to like normal stuff. Just give it like another 5 seconds. So slow. So this is a React app. Now the thing is, when you look at the source code of this application, right? Oops, why is my terminal so sad all of a sudden? What happened? What happened? Is that a different terminal? I don't know what happened to it. That's so weird. Okay. Week 2. So, inside of, like, if you go inside of source/app.js, like, most of the app is here, right? But this is not what the web browser ends up running, right? Whether you're testing it or whether you are building it, the web browser runs the transpiled version of it. And what I mean by that is if you want to build your React app, right? Think of this just like compiling, like you finish writing your program in C, so you're going to compile it, ready for use. I do yarn build. And yarn build is just the command you use to take your React app, which is written in, magical React language, and it transpiles it into something like a ES 2015 piece of code. And we'll find that piece of code together, and I'll show you how crazy it is. Sorry. Just while that's happening, Gauro says, with CSS, is there a way to repeat an element? Like the purple red boxes that make up the shapes. So, short answer is no. The longer answer is that's kind of what we actually use JavaScript for. Because if you're working with HTML and CSS, you'll notice it doesn't feel like programming. It feels like markup. So you'd actually use JavaScript typically to repeat those elements. So for assignment 1, we don't really teach JavaScript for those things. So copying and pasting it is a perfectly fine approach. The main things we're going to be focused on in assignment 1 are people, without the use of JavaScript, are people reasonably copying and pasting it as little as necessary. So I've got this, I've got like week 2 here. I've just built it. Now when you build a React app, it gets built to this folder called build. Let me just move this folder because I can't access it where I am right now that easily. Great. So inside of my 6080 folder here, I have this folder called build. And inside of it, I have tons of interesting stuff. But here's the interesting thing. Watch what happens when I try and load up index.html. Nothing. That's not good. Why is that? That's weird. Oh, okay, one sec. Stupid thing. Just ignore this for a sec. This is not... I'm just trying to demonstrate something. So, this React app, right? We wrote it in React, but have a look at this. When I look at the source code of this page, look at this monstrously ugly thing. And you notice there's all these files here. I've got like a logo, sure that's an image. I have this JSON file. I have this CSS file. I have this, and then 2 JS files. And this CSS file, look at it. It's really hard to read. It's got lots of stuff there. I didn't write that. This JavaScript file, this is what's actually powering my page. Like, what in God's name is this? Is that really all necessary to run the page? And then I have more JavaScript here. So what React has done as part of building it, it has taken its really like simple language and it's basically gone, all right, to express this simplicity in old JavaScript, complex verboseness, I'm going to have to crap out all this stuff. But it sure as hell is going to be very compatible with all the browsers out there. And that's why you can build something in a language like React, transpile it to standard JavaScript, and then bam, it'll work on, like, I could send this file to pretty much anyone with a web. I could put this on the internet now and it would work with pretty much anyone. Not that this is a very complicated application, but that's kind of the power of transpiling. And tools like React would use things like Babel as part of its, that's how React would be built. It would use things like Babel to actually build it. So anyway, that's pretty much it for today. As far as I'm concerned, I've covered everything I wanted to. This lecture I wrote this week, because we did this last year, but it was a little light, and I really wanted to get into a lot more detail with it. So hopefully you found it interesting. Do you have any final questions? Otherwise, we've got like 10 minutes left. If you have any, I can do questions for the next 10 minutes till we wrap up. Zenji said, can the static page change with the window size of task 2? No, so task 2 and task 1 are designed to be fixed in place, and what we mean by that is just that we're comfortable with you hard coding in all the dimensions. So you can just be like, yep, this is exactly this many pixels wide, this is exactly this many pixels tall. You don't have to think about percentages or different window sizes. You can just develop in a window that's bigger than the dimensions provided. Sivo says, how strict is that when it comes to assignment marking? I've been saying pretty consistently to students on the forum that we want your work to look like what we've given you, but we're not going to take marks off people because they were a few pixels off. That's the formal answer. There's no real way to give hyper specifics to that answer because there's obviously thousands of ways people could build pages. A few is like 3, right? So we're talking about like literally like 1, 2, 3 pixels is fine. Generally, the like an untrained human eye will not be able to easily tell the difference between like 1 to 4 pixels in my experience, right? Like if you work with it a lot, you'll be able to notice maybe up to 2 pixels easily, sometimes 1, but for particularly elements that are like maybe less than 100 pixels, but a few pixels off is going to be fine. I mean, you have to remember the point of assignment 1 is for you to be able to demonstrate that you're able to use a language to create something with intent, right? Like you're like, that looks like that, I'm going to make it look like that. Our job isn't to make sure that you like get every single thing pixel perfect, but you know, if a button's 20 pixels wide and you make a button that's 30, that clearly shows that like we can't be sure that you actually were trying to make that button the right size because it's obviously the wrong size. Zixuan says, for task 3, can we use JavaScript for window size changing? I don't remember if in the spec I said that JavaScript is not allowed in task 3. I think I said that, but if I didn't say it, if I didn't ban it, it's too late to ban it. But if I didn't ban it, then you can use JavaScript, but it's just not necessary. It would honestly be more work than it's worth. I mean, I can look that up now. It'll just be easier. So task 3 says, I think I cut some stuff out this term and I must have cut it out. Okay. Oh, sure. There you go. Remind me to add that back in next year. So you can use JavaScript. I just don't think it's going to help much. Using the media queries and stuff discussed in the CSS mobile lecture will be more than adequate. So Yuki says, in task 3, how the single page be identical to the window sized? Well, you just use media. So the media queries, go watch the CSS mobile lecture. It's in the week 3 list. It basically shows you how you can say, given a particular screen size, apply these CSS properties. And if the screen size is that, then apply different CSS properties. It's very easy to do with CSS. It's very doable with CSS, I should say. I wouldn't call it easy. Jeff says, do you think there'll be as much change in web development in the next 10 years as in the last 10? Yeah, for sure. I don't know what. I mean, it'll be a mix of everything. One problem, I guess, that's hard. The only thing that might slow it down is that there's been such a boom in web in the last few years that like it might be hard for people to change and adapt as quickly as in the past. But no, I mean, are those birds annoying? They sound annoying. Have they only been loud recently, or have I only just noticed them? Let me just go shut my window. Jesus Christ. Yeah, I mean, I think it's a mix. Like, you'll see improvements to languages and stuff, like, but you'll also see improvements to browsers. Like, in the last 10 years, it's not just like JavaScript and CSS that's come a long way. It's also browsers. It's browsers. You're able to manipulate the URL directly. You can play video natively in web browsers. There's the introduction of WebAssembly. There's tons of APIs like local storage, which make building pages better. Browsers are far, like, there's a lot to it, but yes, there'll definitely be a lot improved. Frank says, for task 4, I'm having trouble checking if all 4 boxes are checked. Is there something you'd recommend looking at? So, task 4, just to be clear to everyone again and again, task 4 is designed to be the harder part of the assignment, right? Like, when we write assignments, we write them in such a way, just as a rough number, that we expect 85% of students to only get up to 85% mark, right? Not literally, but like, that's the point. So the like harder half, right, of task 4, we write it expecting only a handful of students to figure it out, because like, the lectures are there, the material's there. You actually just have to go and try it and go through the exercises and go through the tute questions and solutions and stuff as they come out. But the short answer to the question of having trouble checking if all 4 boxes are checked, if you think of every box as a Boolean, all you need is a loop or an if statement that checks each of the Booleans. And if they're all checked, if they're all true, then you can do something. If they're not, then they're not. It's really not much more than using some if-else statements and actually capturing the values inside the checkboxes. Hong Tao says, task 3, the page is 1849 pixels, but I don't have the screen size. It's very hard to check whether it's similar to the sample. So if your screen size is a little bit smaller than that, I mean, most screen sizes might be like 1600, I think, at the max. What I would genuinely say is just build it for that slightly smaller width. If your screen is at least like 1600 pixels, if you just build it to be responsive to that width, if you expand it out, it's just going to be bigger, and I think it'll be roughly fine. The other thing you can do is just zoom out slightly, because if you zoom out, like if you zoom out by 25%, you'll need 25% less screen space to fit the same page. Or just build it and scroll across. I mean, sometimes you build like you build when you build a web page, you can't see the whole page on the screen. Sometimes you have to scroll up and down. So it's the same kind of thing. It's like sometimes you might have to scroll left and right if you're on a smaller screen, perhaps. So try those things out. Zenji, for task 4, there's no submit button. I said I'll add that to the screenshot tonight. I know it's missing there. I'll add that. And 5 says there'll be a new CSS property called depth to accommodate common holograms on monitors. That'd be funny. Is that true? I mean, your face makes it think it's like a amuse. But yeah, I mean, exactly. There'll be stuff like that. I mean, tons of cool things I'm sure are coming that we can't even anticipate. But what you should expect, forget improvements in web. It's more just the fact that web is everywhere now. So much stuff you do is in web. Any last questions? Otherwise, we'll wrap it up for tonight. Okay, I mean, some might trickle through, but I'll wrap it up anyway. Any other questions, please post on the forum. I'll always get to them. I pretty much answer every forum question before I go to bed. So, great. Thanks, everyone. Have a great week. Enjoy assignment 1, and I'll see you next week, probably on Thursday. So we'll probably talk about assignment 1 maybe a little bit. We'll see, but I'll see you on Thursday, and yeah, sounds good. Thanks, everyone. I hope you have a great night.